This video is going to be to try to highlight for students how we go about proving sentences. And so what I've done is I've written up over here, first of all, the structure of the proof. I try to color code things consistently so that it's easy for students to understand. I almost always use green for delta, the set of sentences that are going to entail some other sentence, which I almost always write in blue. And so here's the sentence that we're looking to see if it's entailed. That's psi, Q, or A. And here are the set of sentences that we call premises. W implies Q and R. U implies W and P. S and U. So these premises come to us, given to us by some reliable informant, whatever that is. When I'm over here, I'm going to first start, and I'm going to write some metacognitive thoughts down. And I'm going to call them notes to self. And I will abbreviate it as NTS. That's a note to self. So if I'm trying to show that this is true, I only need to show Q or R, or excuse me, A, but not both. So if I were to be able to show that Q is true or A is true, then I could use or introduction to show that that sentence is true. So that's the first step. Then I look at these propositions, and I notice that A isn't even involved in any of my premises at all. So now I'm going to say note to self number 2. I probably need to show Q, and then I will use or introduction to show Q or A. So how can I show Q over here? So if I could somehow show W, then I could use implication elimination to show Q and R. Oh, and then I could use and elimination. So here I'm going to write a note to self. Note to self, show W, then use and elimination to show Q. And remember, if I could show Q, then I could show Q or A using or introduction. So how do I do that? I got to show W somehow. So let's see. Oh, this is so easy to do. I'm going to say right here, this is kind of a step. I can show S and U using and elimination. So, and if I can show U, then I can show W and P. Okay, so I feel like now I know what to do. Here's what I can do. First I need to show U so that I could use it to show, okay, let me show you what I mean. So let me write here in black. I'm going to say that I know that U is true, and that's from and elimination, step 3. You see right here, if S and U are true, then I know U is true, because the only way for the conjunction to be true is if both are true, both of the propositions. Oh, so what does that get me? Oh, look, these two together get me W and P. That's implication elimination using step 2 and 4. Because look, that's the implication and that's the antecedent. And we know that when the implication is true and the antecedent is true, then that means that the consequent has to be true. Okay, so now I'm a little bit lost. Oh yeah, I need to show W. That's what I need to show. How can I show W? Oh, yeah. It's easy here. W is true from and elimination from 5. And that's the same thinking as I used here. Oh, now I feel like it's starting to come through for me. So now I know that P and R are true using these two right here, because again, this is implication elimination. That's from step 1 and step 6. So what I'm saying here again is, if I know that the antecedent is true and the implication is true, then the consequent has to be true. That's implication elimination. That's a really important step. Oh, now I'm a little bit lost again, and I forgot what I'm doing. Oh, yeah. I only need to show Q or A. I really need to show Q because A is not involved. So can I somehow show Q? Oh, hold it. I made a mistake here. That's not P and R. That's actually Q and R. Got to be careful. See, that's Q and R there, not P and R. So can I show Q? Oh, yes, because this is very easy. Here, this is Q because of and elimination from step 7. So now I have Q. And remember, I just needed to show Q because now I can use or introduction. That's, yeah, okay, so Q, Q or A using or introduction on step 8. Because remember, if we know that one proposition is true, then the disjunction or the or statement with any other thing is also true. So yay, I think I've proven it. Okay, so what did I do? I kind of worked backwards a little ways, and then I looked at my premises and tried to make a connection between my backwards work here and how I might get to that over here. That's our strategy. That's like a strategy that's tough for students to understand, but we got to help them. So now what do I conclude? I conclude this. I conclude this. Actually, I want to put this in black. That means that psi is provable from delta. That is to say, these premises can be used with rules of inference to prove psi. And what that also means is that delta entails psi. And so a sentence that I would want to write in English or in natural language is if the premises are true, then the conclusion must be true, must also be true. That's through provability. And so I'm going to say now my final thing is to say that delta, I'm going to say, entails Q or A. Or another way to say that is these premises entail Q or A. So again, kind of the strategy is you kind of like have to get this set up in your mind before you start doing it with students, like kind of practice it a little bit and say, all right, I'm going to start off with these premises, this set of sentences that's called delta, that we know are true from some outside source. I'm going to try to prove this other sentence or use some steps of inference, rules of inference to go step by step by step by step until my final line is the conclusion that I want. That's the whole game. That's called proving something.